Okay, let's get rolling.
There we go.
So we have a lot to talk about today. We have a lot to talk about, so I want to get going. So the first of four things that we're going to talk about, four approaches we're going to talk about, I'm going to go talk function and physical. That's the one we just discussed, okay? Because I think that's more interesting because we've just done exercise. And you miserably failed, right? Good. So, a word, architecture, right? It's used in many ways. If you hear architecture, maybe most of you think of this, right? If you're geek enough, then you think of this, probably. Because, this is the domain, the architecture, the word architecture is often used. But we're using system architecture today. And here are some definitions. There are some different definitions in different books and different people. So this one says the arrangement of function and feature that maximizes some objective. Okay? The second one says fundamental organization of a system embodied in its components, their relationship to each other, and to the environment and the principles guiding its design and evolution. Or relationship between system and its context and elements which constitute a system and the relation between elements. Okay? So basically it's telling you the same thing, but I think many of you, when you hear system architecture, you expect software. I don't know, electronics, 5 volts, 12 volts, I don't know what, those things. But this definition says nothing about them. Nothing about software, nothing about electronics or whatsoever. It just talks about functions and maybe features and objectives and components and relationships. Again, I think I've been using these terms over and over since this morning. But so the architecture is about how you arrange them. Okay, how you arrange them. So let's stick to the arrangement of function and feature that maximize some objective, or let's stick with this one. System and its context and elements and its relationship. Okay? Keep that in your brain. Okay? Pop quiz again. Which of the following have the same architecture? And your packet has the answer, so don't look. Anybody? Okay. Okay, above 2 and then the bottom 2. Why?
Because above to use something instrument,
The
and
tool.
you lock it or your tool.
Yes.
But bottom 2 is just hand or foot.
Okay, it's a bare hand or a bare foot. Oh, I mean, of course they're wearing shoes or something, but... Right, okay. That's one perspective. Some other ways to see the similarity in architecture. Yes?
Except for the baseball,
Yes.
all of them use nets.
Ah,
So we don't see it in soccer, but
okay. So the net is the essential element, the physical element in each architecture. The 3 architecture, but this one not. Okay, that's one way to see it. Okay, go ahead.
The baseball and the tennis are used to racket,
Yeah.
but the 2 down there, they use their body to hit the ball.
Okay, yes. Indirect and direct, yes. Other way to put it? Yes. Let's hear from the other guys. Yes.
except soccer,
Except soccer, all the same. Why?
using by hand.
Oh, okay. But there's a goalkeeper.
Oh.
So, okay, that's a good example of not being messy, right? Because there's a confusion. If you say they all use foot or hand, then what about the goalkeeper? He doesn't exist anywhere. So I mean, he doesn't belong anywhere. So, nice try, nice try. But most of the players uses foot. Yes, true. Yes.
So all of them are wearing shorts and t-shirts.
I mean, the way they dress, 3 of them are alike, and the baseball is not so.
Okay. So the clothing. All right. The lady in the back.
I would say except tennis,
Yes.
because all the other ones have a lot of team members.
Ah,
And
okay.
you have to position them in the right way. So I
Okay,
would
tennis
say
is just one.
one
But what
person,
about doubles?
doubles, but then it's two people. It's not a huge team. Like you
Okay.
don't have to decide who is where.
All right. So for you,
Positioning.
3 or more is a lot.
Yeah,
Okay, good.
yeah.
All right. That's one way to say the number of players. Yes, David.
Everyone play with ball.
Everyone.
Play with a ball.
Okay, so you're saying all 4 are the same architecture using the ball. Okay. So, okay, yeah, let's stop. There's so many other ways to put this, right? If you look at the field, right? Maybe the field is separate from their field and our field. That's tennis. And then the volleyball. But baseball and soccer, there is no their field or our field. Right? And of course, maybe you can look at the time. Okay? Time is restricted in soccer, but all the rest, there is no time restriction. But there is a quarter or whatever, the phase restriction. Right? So there's a difference. So, it depends on what you look at, but for now, let's stick on to function and physical elements. All right? So architecture that human and a ball interact directly. Okay? And this is the architecture that human and a ball interact with a tool in between. That's the architecture description of these two groups. You agree? Okay. Now I'm going to describe in a specific way. A little drawing. So my physical elements comes in black boxes. Okay? And my behavioral element or functional element comes in this purple bubbles or circles. And interrelationship is my orange arrow. So let's stick to that legend and let's see how I can draw this. Human exert force to the ball, right? And then the ball flies. So here's how I draw. Human in the black box and the ball as a black box. And here's my purple. Exert force to the ball to fly, and the ball flies. And there's an interface called force. Agreed? Yeah? So let's see the other architecture. Human exerts force to the tool. Tool exerts force to the ball. Ball flies. Okay? That's the description. I'm going to draw the description. Human to ball. Human exert force to the tool to move. Tool exert force to the ball to move, fly. And the ball flies. And there is the force in between. Okay? Now you see clear difference in two architectures. Right? It's abstract notation, but these two architectures are clearly differentiated. Yeah? Let's do this. Okay? I take out that and change it to, I'll take that out too, to exert force to the ball to roll, and the ball rolls. What is it?
Hockey, golf.
Bowling, the other answers? Yes, one is bowling. What else? What's that?
You roll the ball to another ball.
Yeah, there is that kind of game, but I don't.
That kind of game. I don't know. Do you know this? This is in Japanese traditional, how do you say, physical education sporting event. Okay, in elementary schools, you have this crazy big ball and you roll, and I don't know what you're competing, but I don't know you take a turn and it's just fun. It's just crazy. Everybody gets fun. But that's that. Okay. And what about golf? Is golf this architecture? Why not? Right, they hit and flies, right? So it's a combination of the first one and the second one, probably. I mean, the other one, the tools. All right, and I'm going to change this architecture to shuttle, and of course that to shuttle. Now what is it? Yes, it's a badminton, right? Okay, so so we can see architecture, and then there is designs following that architecture. Different designs are possible. following the same architecture, or different designs have the same architecture. And it depends on how you define your architecture, but one architecture can have different designs depending on the context. All right? So here's the other definition of system architecture from MIT. We have a very close relationship with MIT Engineering System Division. They're SDM, they're called SDM. And so their definition is this: system architecture is abstract description of the entities of a system and the relationships between those entities. Okay, so that's their definition. And here's a very interesting thing about the system architecture they describe in their book, or it's actually PDF. If you type in this, you can download their PDF. It's quite interesting. If you're interested, please take a look. So this is conceptual diagram. Once you know or you define architecture of a system, okay, it has great effect on four things of your system. Four things. One is function behavior. These are the system behavior that you design, okay, that you are willing to have. Okay, so once you decide your architecture, it has great effect on your function design, your intended design, okay, function behavior. But at the same time, once you decide your architecture, it greatly affects emergent behavior. Emergent behavior meaning that's something you did not expect, but you happen to have as a consequence of choosing certain architecture. Okay? For example, the architecture of a car, automobile, if I put it this, let me put it in this way. You have four rolling things, okay? Four rolling things, aka tire, okay? And you have a platform sitting on top of it. True? That's an architecture. Let's put it that way. And this architecture gave us function behavior of going forward, backwards, and moving around. We gained that behavior, right? Because of this architecture. But at the same time, what is the emergent behavior that we got? It can kill human. Right? Because of this architecture, because of this four rolling things on the ground and the platform on top of it, we gain functional behavior of move forward and backward easily, but at the same time, we happen to have this emergent behavior of killing people, hitting people, right? So the mind twister is, then what is the better architecture for a personal vehicle so that it does not kill human? So, there is no answer for that, but, that's the way you think, okay? Because of this architecture, we gained some functional behavior, but we are suffering with emergent behavior. And once we decide on the architecture, it has a great effect on the system complexity. Yes? Yeah, go ahead.
Can I ask a question?
Sure, yeah, go ahead.
So when you say emergent behavior,
right.
This is not... so you just made an example of killing people.
Yeah.
But this is obviously something that doesn't happen every time you drive a car.
No.
So emergent behavior, what I expected you to say was like, inside the car, people's bodies are affected by force and inertia, which would happen at all times when the car is moving.
Yeah.
But this, this effect, emergent behavior doesn't necessarily have to be something that happens at all time when the function is behaving.
Right. True.
Okay.
Yeah.
It's just a potential effect.
Right. It could be something like what you said, like a side effect thing. Like basically that's a consequence of the main behavior, right? Mm-hmm. But it could be something like what I said. The temporary. It's non-obvious, but it does happen, right? Okay. Yeah. So another great example.
It could potentially never happen if you're really careful.
Well, yes, but architecture-wise, it can, right?
Okay.
It's possible.
Right.
Yeah. So again, nuclear power plant. What was the functional behavior? Produced and generate power, right? Constant power with a very small effort. But what is the emergent behavior? There's so many that we cannot describe here. And we're suffering. So, yeah. Okay, yeah. Okay, but that's a good question, good question. So, it's just very conceptual, very simple diagram, but what it's saying that you're, of course, designing your architecture towards this, but you always need to fight with your consequence, right? There is a consequence of choosing certain architecture. So you want to be very careful about your consequence. And the nuclear power plant I think is a great bad example of that. We pursued the functional behavior too much and little forgotten about the emergent behavior. But I don't know. Maybe the people in the past have tried, but we did not have the technology to anticipate that. But okay. So, and architecture has a great effect on the complexity of the system and a great effect on ilities of the system. Ilities is a very systems engineering term. It's usability, operability, durability, all those ilities in parentheses. I mean the double quotation. We just bundle them together and call it ilities, or the characteristics of the system. It's I don't know. It's a cute way to put it, I guess. So system ility is something you want to control, like safety, reliability, or those things. You want to maximize that using your architecture, or sometimes you want to optimize in some ways, like minimize, maximize, balance, things like that. So I think it's a great description of how architecture can affect your system. Okay, don't take it too hard. It's just if you decide an architecture, and a lot of different things can get affected. All right, good. So pop quiz. See, I told you I have a lot. Describe the architecture of the following system. This is a bamboo skew. It's a stick. Yeah? Just like you use in a Japanese barbecue or the yakitori, the barbecue chickens, or is it chicken? Yeah, right. Tori, yeah, maybe chickens. I don't know. Yeah, some bird. Yes. Okay, so I have even though I have a four in the picture, I want you to be looking at just one bamboo skew. Not instead of four. Just imagine you have that in front of you. Just one. So the question is it even a system? Right? But I'm telling you, it is a system. Somebody describe the architecture for me. Anyone want to try? Yes. Brave. Sasha?
Sasha, yeah.
Okay, Sasha.
I think there is a part when we hold it in the hand.
Yes.
There is a part where is the food.
Yes.
And there is one part when it is used for picking.
The sticking?
Yeah.
Yes. Yes, exactly. Thank you. So if you look at just the physical element, there's just one thing, right? The bamboo skew. But again, the viewpoints. You forgot about the functional viewpoint. Now you see multiple elements interacting. So food sticking function, right? And to be held function, right? And there is a physical element called bamboo. I don't know if it's really bamboo or not, but some kind of wood-looking piece, okay? So now you see multiple elements interacting. I mean, physically connected in this case, right? So again, you need to wear different glasses to see elements. You cannot just be looking at physical element, because that glasses just can show you one thing. But if you wear functional viewpoint glasses, then all of a sudden you see two functions, or more maybe, right? So this is the way I describe my bamboo skew, okay? So there is a physical element, bamboo, and then there is a to be held function, and then the food sticking function allocated onto it, okay? So definition of architecting is allocating functions to element and clarify the relation or the interface between the elements. Very simple. So let's try this. Okay, let's imagine, I'm still talking about bamboo skew, but you are the first one who invented this concept, okay? Maybe you're some Chinese chef 6,000 years ago. or even further back, I don't know when. Okay, your design purpose is I want to fasten pieces of meat together when I roast it. Okay, that's your design purpose. Okay, and you have kind of that in your mind, but you don't know yet. Okay, just don't think you know that yet. You're the first guy who came up with this concept. Okay, so I'm gonna take you through the architecting steps. All right, so this is I have in my mind, and I start design my functions. What should I have? What function should I have? I need to have maybe food sticking function somehow, right? And then it needs to be held by hand, okay? And then you start to think, how do I do this with physical element, okay? So maybe I have bamboo in the back of my yard, so maybe bamboo is a good choice. And then you think, okay, I'm allocating these two functions to this bamboo element. Okay, here's my architecting result or system architecture description that I have. Okay, now I have this. Now I'm moving into the actual mechanical design, right? So, okay, now I take bamboo and I tweak around, do other things, or maybe I do some calculation. And I get this. This is mechanically designed result. Okay? So it's a very high abstraction level design, right? That can help you to come up with the final solution. Okay? I may be able to choose, I don't know, iron, if I were able to choose that. Iron instead of bamboo. Maybe I were able to choose, I don't know, animal bone, if I was good enough to craft with it. So it depends. It depends on your skills, your availability, and context, and everything. But this conceptual design help you to design the fundamental of your solution or your concept. You understand? The architectural design and actual designs are different in abstraction level. All right? Good. All right. So definition of system architecture is a relation between systems and its context and elements, which can constitute a system, and the relation between elements. So this is an example of a function in physical architecture. So it has some function. Physical elements have some functions, right? And then it's interconnected. So basically, system design is almost nearly equal to architecting. You decide what function to have, and you decide which physical elements has that function. All right? So that's your choice. That's your choice. So I hope now you're feeling you have more degree of freedom of choosing the design option. Not only the physical design options, now you have a functional design option, you have an allocation design option, and you have a physical design option. Now you're already open up to 3 design options. So, meaning more fun. Yay, your turn. Okay? Now you're going to do this. So there's basic 2 steps of architecting, and actually this is taken from, for those who are geek enough to look up, it's from IEEE international standard called Standard for Application and Management of the Systems Engineering Process. If you're interested, go look it up. I'm taking just 2 steps out of it. So first step, define functions needed to achieve the set goal. Okay, first step. And to do so, design the logical order of the functions. That's what you do. Second step, define physical elements which realizes the functions. Okay? And there's 2 minor steps in between inside. Design hierarchy of physical elements, and then allocate functions to physical elements. I'll take you through. Okay, here's an example of design purpose of executing household duties. Okay? Here's functions. Food cooking function, do laundry function, room cleaning function, taking out garbage function. Okay? Those are 4 functions. And physical element. There's me and my wife. Okay? My kid is too small. I'm gonna make her do it soon, but no. Currently, there's 2 physical elements that I can choose. Now I'm allocating. Me doing laundry function and taking out garbage function, and my wife is doing food cooking function and room cleaning function. And the communication in between. Ta-da! Happy life, right? And I often forget this, and oh my God, there's a big yes. Right, you know, Mondays are that, and Tuesdays are this. You know, that's how you live in Japan, right? Okay. So simple, all right. Don't get too scared out of you know, the big words like architecting or system architecture. Don't. It's easy. So design purpose. The second example: cooking a dish at well-established restaurants. Okay. Here's my functions. Here's my functions to this. What do I need to do to cook a dish at well-established restaurant? Okay? There's many steps. You know, just this is a simple example. I'm just taking each steps apart. So peeling function, okay? Peeling, and then cutting function, right? And then boiling function. You know, think of the vegetables, okay? And then flavoring function. You need to flavor it with some spices and else. And serve it on the plate function, and then table serving function. Yeah? Okay, now physical elements. I have junior apprentice, I have senior apprentice, and I have a master. Think of Japanese old restaurant, okay? He's like 95 years old. Okay? And this guy's senior apprentice, but he's still apprentice, he's in 50s. This guy's 23, good luck, right? He has all the way to go to become a master, but that happens. I think maybe in India it's longer, maybe, I don't know. Yeah. So now I start to allocate, okay? Allocate, so give these functions to the elements, all right? Here's what I did. Junior apprentice peeling function, of course, yes. Cutting function, of course, right? Of course. And then you give peeled, pre-cooked vegetable to your senior apprentice. And he'll do the boiling function, because you know there's a technique of doing, you know, dealing with the fire and I don't know, everything. And then now there's a boiled vegetable. And here comes the master. He does the flavoring function, okay? Because that's his recipe, his secret recipe. And that's it. Okay? And then cooked vegetable is interfaced to the senior apprentice. And he serves on the plate because there's a technique, certain technique. It takes about 15 years to, you know, get it. Alright? And here comes back the cooked vegetable on the plate. And it's now your job to go serve it on the table. So, ta-da! This is the architecture to serve this design purpose cooking dish at a well-established restaurant. Okay? Easy enough? Okay, good. So, now it's your turn. Okay, so here's the steps. Define high abstraction level functions. Okay? You need to be very careful about this. If you go dive into very low level abstraction functions, you'll die because it's going to be an explosion of functions after functions. You're not going to be able to design whole thing. Okay? Try to keep very high abstraction level. Okay? It's important. And a logical flow of your functions. Okay? And here's what I'm going to do. I know the team is mixed. Okay? So choose one people in the team right now. Just do what I say. Choose one people in the team right now. Just pick one people. One person. Chosen? Just choose one. Pick one. So somebody were here yesterday. Okay? Somebody who was here yesterday. Okay, good? Good? Chosen? Who is it? I want to see hand. Who is it? Who is it in your table? Yeah. Okay. Alright, good. Okay. Do you remember the idea you were prototyping yesterday? Okay. Describe that to your friends. Okay? That is your idea now. Now you need to design functions for that. Okay? Okay, wait. I will show you another example before you move on. Okay? So here's what you do. So let's say, tailor-made exercise menu providing was an idea, okay, for the healthcare, whatever. And the functions, okay, to keep pay attention to the level of abstraction I'm staying on, okay? And I do it with the post-it notes. So this is how you do. Okay, how can we serve this purpose? What functions are needed. Okay? And don't get stuck with how you do it. Okay? Think of what functions are required, regardless of how you realize it. And it's tough sometimes, but just forget about how you're realizing it and try to focus on what functions are really absolutely necessary. Okay? So here we go. Function to evaluate the physical characteristics of this person is probably necessary, right? Because I want to tailor the exercise menu. Alright? So that's probably needed, okay? This is, like, doing the discussion, maybe a little brainstorming and deciding, hey, this is necessary. Okay, and then what? And then what? And you go, okay, when this is done, the second function should be function to generate tailor-made exercise menu, probably. Okay, yeah, I agree. But to do so, maybe it's better, this is like following your discussions. Maybe it's better to have function to prepare different types of exercise patterns so that I can use that as a building block for my exercise menu, right? Oh, okay, yeah, I agree. And then now maybe I can go to function to provide tailor-made exercise instruction. How about that? Okay? Now you have your functions designed. Okay? And you can of course tweak around, you can change things, but keep the abstraction level very high. I don't know how to do this. I have no idea yet how to realize this. But I know this is necessary. Okay? These needs to be realized somehow. Okay? And stop here. Stop right here. Okay? Alright? And maybe I'm just showing you the next step. We're not doing it now, but I want to expect you to do this later. But here's the physical elements coming in. Okay, now I have these functions. Now I start to think who or what does it. Okay? So I can go and say, I want my new company to take care of these. I'll have my men and women do this. Right? And let me think. How about trying existing cloud service with their other user information to generate some patterns for me? Let's try to find some service like this that existing so that we can take advantage of. What about this? Function to evaluate the physical characteristics of the target? There's many options that we can take probably. How about like a wearable device? Yeah, maybe. But maybe we can do like a private coach. I don't know. What should we do? Right? That's the type of discussion you can have. Just separating functions and physical. But, if you don't separate them, you might start talking about your wearable device without looking at the whole picture, right? Because this whole picture is what you want to achieve, not just the device, right? Usually, because device is not a value. This whole picture provides your customer a value, right? So I think by following the steps of thinking about the purpose, designing the function, and then the physical element allows you to talk about values more than the physical element. Okay? That's how I think, and I hope you feel that when you're doing this too. So you get it? Okay? Like I said, very important point is that you need to focus on the most important functions. Don't talk about bells and whistles yet. Okay? Meaning, 細かい話をしない方がいいですよ. Try to focus on very important ones only. And again, keep it at high abstraction level. Okay? And some of you may be good at controlling the abstraction level, some of you may not be. Collaborate. Okay? Collaborate. Alright? And discuss what functions you need to realize. You need to realize your idea. The idea that the guy or she has. Okay? Alright. I'm gonna give you, 30 minutes. 30 minutes. Okay? So you need to describe